We are coming into the module that probably is one of the densest in terms of information for this course. In this, in order in order to give it full attention, Module 9 will be split into two. Module 9A, 9B. Module 9A will concentrate on growth. Module 9B will concentrate on maturation. If you recall, this is a development course. The overarching principle is development. The two pillars of development are growth and maturation. Let us proceed. A specific focus of this module is to concentrate on how we measure growth or the increase in size. And ultimately, we are going to look at how this affects performance, motor skills, in other words. To start us off, here's a picture of a child born at 19 pounds. It's kind of unusual because this is a kid born in Asia. He is purely Asian, has no Caucasian roots, yet 19 pounds is just think is inconceivable. It actually happens. For reference, a 7-pound baby is shot alongside him. How do you think the growth of this child will ultimately affect his health and, specific to our course, his motor skills and performance? Given that our thrust in this unit is measurement, the term anthropometry should be quite familiar. Anthro, for those of you who know what anthropology is, it is the study of humans. The suffix metry has something to do with measuring, therefore, measuring human growth. The two most common measurement variables are height and weight, easily measured, tape measure and a weighing scale. These are quite understandably the most often and easily used. We proceed with segment lengths, segments having to do with anatomically defined segments such as your head, your trunk, your lower extremity, your upper extremities. We will also talk about body breadth measures, how wide certain sections of your body are. Biacromial bicrystal ratio is a compound measure, but both of which use body breadth measurements. Acromial processes are part of the shoulder, therefore biacromial refers to the width or the breadth of the shoulder, bicrystal, width or the breadth of the hip. Lastly, we are going to talk about circumferences. Especially to a neonate, one of the most common measurements for a newborn is the head circumference. At birth, one of the most important measurements is the head circumference. If the head circumference is larger than what is average, usually the risk for what you call the hydrocephalus condition is high, and clinicians are always very careful when it comes to this. We look in terms of how the averages, obviously. Typical average weight for American babies, depending on which data set you look at. Here it says 7.5, more like 7 to 7.5 if you look at the range from different data pools. By the end of the first year, an infant is expected to triple his or her weight. Thus, year one alone, it is anticipated that the tripling of the weight, obviously, is equivalent to a 200% increase in actual poundage. If we juxtapose the weight increase to the length or height increase, by the way, infants do not have heights because you cannot let them stand up. The only way to measure infants will be at length. There's a special weighing scale where the baby's weight and the length is taken at the same time. But here we want to compare the increase in weight as opposed to the increase in height. Whereas one increases by 200%, the length increases by 50%. In this module, it is important that students are aware of growth charts and how to read them. We will discuss this alongside important concepts. The first concept is position, distance or position curve. When you look at a growth chart, such as this one, it's a standard growth chart, literally what happens is you plot the infant's weight across time. Let's take this sample kid that we took. I hope you see the red dots. If you make an estimate of this kid, you would, yeah, this is just an estimate, maybe about 70th or 80th percentile. So I introduce the word percentile here. You know the difference between percentile and percentage. Look it up. This is expected of you. This is not a math course. Nevertheless, when you think in terms of percentiles, focus on the edges of this family of curves. There are several numbers there. It says 5th, 10th, 25th, 50th, and 75th. Everything else is covered up there. If you look at a comparison child who's, it's a little bit murky here, but in light green color here, a kid is measuring at 45th percentile, below the 50th percentile. If you understand the meaning of percentile, does that mean this child is underweight or at risk for malnutrition? 50th percentile merely means that within a population of children, they are smack in the middle, 50th, about 50% above and about 50% below. For a child to be at 45th percentile doesn't mean much. It could be an Asian baby, and we know anthropologically Asian babies tend to be smaller. So within the context of the American population, Asian baby, 45th percentile, rather small, but all else, by all other indications, is healthy, should not worry any parent. So here again I emphasize, this is a distance curve. It is your location in time, in a two-dimensional space. X dimension here is age, Y is stature. This happens to be in centimeters. Therefore, lengths I believe this has to do with males. Now, a square has come up in there. You would likely think that some upheaval in growth occurs in this teenage years. What could that be? Most of us are familiar with the term growth spurt. Okay? If the question is when does that growth spurt begin? Good general answer, maybe somewhere in between 9 to 16. But as in any science, you want a more precise number. It is not as easily readable if you're looking only at a distance curve. So this is where we introduce the other concept. To identify growth spurts, it will be much easier to look not at a distance curve, but a velocity curve. Velocity, as most of you who drive know, that it's the spurt. It's when you speed up. So when you have a velocity curve, you can plot when the speeding up of the height curve or the length curve or the weight curve occurs. Regardless of which variable, a velocity curve generates numbers to tell you where you are growing the fastest. Take note, this is a chart, this is a graph. I actually hand drew this. One of them is in orange, the other is in green. Why are there two growth spurts here? If you guess that it has to do with the genders, you are correct. Which one do you think is in the orange and which one is in the green? Ladies, if you predicted that girls grow faster or at least ahead of the boys, you are correct. The ladies' numbers are represented in the orange curve, the green one for the boys. Again, this is a velocity curve. Why is this so important? Why would you want to know when you're growing fastest? Well, you always have to think in terms of the grand scheme of things. If you are growing the fastest, and what happens if that growth stops? What happens if that growth spurt never happens. Um, it typically becomes critical when something out of the ordinary happens. So to recap, reading growth charts, this is important. Percentile rankings, whether it has to do with height or weight. Typically, when you have a growth chart, you have a family of curves detailing what a normal trajectory is for people in the fifth. Obviously, it goes all the way to 99th percentile, fifth to the 95th, depending on which company publishes the numbers. Some would use third to the 95th. 97th, sorry. Doesn't matter. It's pretty standardized. The distance curve is an absolute score of your position in time, which is specific ages, and your velocity curve, on the other hand, is a rate of change, just as you measure in biomechanics or in physics. Delta D over delta T is the rate of change as a function of time. Step back a little bit, you always assess it in terms of what's appropriate. In terms of percentile ranking, what you look at for are numbers that basically ring the alarm bells. What are the red flags? Anybody greater than 90th percentile or anybody below the 10th percentile, both extremes will have you scratching your head. What's going on in here? In addition, when there are significant deviations that occur within such a short period of time, please take note. Typically, at 2 to 3 years of age, a steady relative position, in other words, where you are in the grand scheme of the population. If you tend to be a small, wiry child, baby, you tend to keep that relative position from childhood to adolescence to adulthood. Whereas if you come from a family that's kind of stocky and big boned, you do know that your relative position, whatever that is, it's the same kind of pattern. Right about 2 to 3 years of age, you attain that steady rate and you carry it over throughout most of your childhood up to adulthood. So let me go back to the significant deviations. What happens if there is a significant drop or increase in such a short period of time? Large change has to be accounted for. Is there something in the environment that caused either extreme obesity or extreme malnutrition? Was there abuse? Was there disease? Was there a social upheaval in the life of the child? Were there family issues? Were there family issues that need to be dealt with? When we combine both height and weight, BMI is a number most exercise scientists are familiar with. It is expected from ESS 3314 students that you know what body mass index measurement represents. I need you to know the unit of measure. Weight is measured in kilograms, height in meters. It is a metric measurement. I know it is not par for the course in the United States to be using metric, but do so in this case. It's the only one accepted. I'm introducing a new word here, dimorphism. Di means two, morphism has to do with form. Yes, it changes. Your morphology changes, but the word morphism itself is referring to the form. And if you note the icons on the right and the left, what does dimorphism mean? It means two forms, and those forms relate to the two genders. And so when it comes to growth, do males and females grow similarly? The answer is no, because somebody grows first. You've alluded to this in the velocity curve already. If you look at the figure in the text, it talks about a mid-growth spurt. And this phenomenon is more likely to be seen in females than males. Between 6.5 to 8.5 years, females experience a mid-growth spurt. There's a little bit of a plateau after that, and the adolescent growth spurt begins later at about 10 to 11 years. So the onset of the spurt. Please take note of the terms that are being used here. Onset. It is the beginning of the spurt for females between 10 to 11 years. Please take note that it's not written in stone. You're being given a range of ages because it's not the same for everyone. For the males, the adolescent growth spurt begins approximately 2 years after the females have begun theirs. So, to answer the question, how do males and females differ in terms of growth, in terms of morphology? Females grow first, but in terms of absolute increase in size, that's a different story. Knowing the fact about the timing of the growth, who likely experiences the adolescent awkwardness? Males or females? Just in terms of the timing, okay? The females experience approximately two growth spurts, a mid-growth and a real growth spurt. Males unlikely to have two, more likely just one. And for the males, it tends to happen later in life. When it comes to adolescent awkwardness, or in other books, they will be termed as clumsiness, it is more likely that males will experience the adolescent awkwardness to a greater extent than females, although females are also uh, more likely the ones to grow so much taller. It doesn't happen to all males. Please take note. There was a discussion in your book about how clearly adolescent awkwardness affects or actually disturbs the balance more clearly among the most skillful males at the very beginning of that growth spurt. If you think about it, if it was just an ordinary kid who's not so well involved, who's not so skillful, doesn't train at elite levels, a little bit of change in the body is no big deal because they're not using it to the level that the elite performers do. But when you have kids that are, they're the star of the team, and all of a sudden their timing is off, they're growing so quickly, they're more likely to be bothered by the awkwardness. And it's usually at the beginning of that growth spurt. Basically, when the structure changes, a level of adjustment needs to be, done. It involves both physical and motor adjustments. This last set of concepts that exemplify dimorphism uses a more visual approach to compare both males and females. So, in terms of males and females, who do you think is shaped? So, this has to do with the shape, shaped like an apple or a pear. I mean, we can visually do this, but if you want something that's more quantitative, there is a way to measure this, and clinically it will have its own use. But for now, let's define it first. By apple, typically it's top heavy. For the males, having broader shoulders and barrel shaped chest would typically associate the apple shape to the males. For the ladies, given the pattern of adiposity where we lay fat on our hips and the thighs, the probabilities are, in terms of shape, we are the pairs. But if you want to quantify it, as I said, you've already been introduced to the ratio, biacromial bicrystal ratio. If you look at the ratio of the shoulder to the hips, it's represented by these trapezoids. When the numbers are greater than 1, you have a greater numerator. You expect this from who? And you expect this from whom? I will not answer this. I think it's obvious. I need you to interact with this slide. You answer that question. It will be in the exam. Looking at the same sample child we looked at earlier, we've already tackled the idea of a change of changes in size. Now we will be looking at specific changes in proportions. As much as we're growing in size, different body parts grow at often an asymmetrical timing, meaning proportionally there are some differences, particularly between males and females. Okay, but for now, as a general thing, figure 616 of the text is here. A little bit of a variation because this is hand drawn. I would like to go through this with a little bit more clarification. So proportional changes in terms of segments. If you look at the head contribution to height, at birth it starts out 25%. By the time you reach your normal proportions as an adult, it has shrunk in its relative contribution to height. As much as the head is decreasing in its contribution to the height, something has to increase. Okay? Clearly, it's not the trunk because the trunk has remained 40% relatively, at least in estimates, anthropometric estimation. Therefore, if you look at the numbers themselves, it is the leg length increase that takes up that increasing proportion. What does that mean in terms of growth? What does that mean in terms of performance? What does that mean to the child personally? Okay. Want you to look at this picture. I know it's a little bit blurry, but on the right is an average male. Well, I don't know how average that is, but this is a picture that juxtaposes or puts side by side your lanky teenager on the left and your full-grown adult on the right. I know what pops out to you probably because of the fashion. It's not like high-waist pants are the norm today. But if you look at the proportion of the legs, it's one of those things. The increase in the leg length for boys must be exponential or tremendous once their growth spurt begins. So if you look carefully in the timing, leg length increase precedes the shoulder width increase. In other words, they're going to grow lanky. They're going to grow awkward because those legs are just going so quickly. For those of you in your own personal experience, there was a time in your life that your moms were wondering why you need new pants again or why you're tearing up your shoes. She just bought it, a month ago. That period of tremendous growth just ushers in a lot of anthropological, physical, and motoric changes. Before I go to the girls, another issue that's going to be talked about, apart from the differences between legs and shoulder, is the filling out process. In other words, it's the laying of muscle and it's the laying of tissue over that increasingly taller frame. And that happens about a year behind. Okay? Now, what about the girls? Well, the filling out issue is quite different for girls. For the boys, it's laying on tissue and muscle. For the girls, biologically, we have a different construction. Girls fill out in terms of the adipose tissue because they are the ones that have to be lactating when they have a baby. Think about that whole era of growth when you become an adolescent. It's basically the ushering in from being a child to being an adult, marked by the maturation of the secondary sexual organs. We will discuss this further in Module 9b. For now, please understand obviously growth and maturation are related, but you cannot really discuss growth without maturation in this case because it's just a different pattern for the boys versus the girls. Other issues, let's keep for now the discussion, the issues on growth. When you start looking at differences in height and weight, let's assume these two boys are competing for a white belt martial art event. Let's assume these two kids are both, let's say, 12 years old, but one is almost a head taller than the other. I suppose a lot of people will say, yeah, it's fair. It's an all comers meet, all white belt. It's about skill. But if your child is the smaller child, will you have at least a bit of concern? Is it fair? Because if age is the basis for competition, it really puts the little ones at a disadvantage. Notice that in a lot of other martial arts or competitions, especially in the Olympic levels, there is parity established by making sure that people compete in terms of weight classes, okay, not of age, lightweight, heavyweight, etc. So then, at least there's parity, and so you compete on the basis of skill. Okay. Another thing, I know it's not very obvious in here, but what happens if a boy and a girl compete against each other? Okay. Would that bother you? Would that be an issue? Nothing is going to be resolved by these slides. I merely want to bring this up because when you start talking about growth, it is an issue. There is an age where the girls actually grow faster, grow bigger, where the girls almost equal the boys in terms of heft and size. We're going to talk more about that in maturation later, but for now, let's concentrate on simply measuring growth. There is another measurement in terms of physique. Another term that is used interchangeably is somatotype. Soma meaning body, type, somatotype. Okay, here in that section of the chapter, you're going to talk about endomorphy, ecto, meso. It has to do with the shape, but there is a quantification of this. We will not go into detail in the United States. In fact, this is not as much used as it is used in countries like China or previously in the Eastern Bloc of Europe, which is no more since but then again in Russia it's they've done this, the old Soviet machinery in sport somehow is still, some sections of it are still working. So as far as recruiting athletes for a certain sport, they have it down as a science. But suffice it to say, for this course, all we're going to talk about is the terms involved, a little bit of cursory view of how they're measured, but beyond that, the actual measurement, we do not have time to devote for that. What you have here are different shapes and their associations. So when you think in terms of scoring children in terms of their physique, there's a scoring component with the lowest number of 1, highest 7 per component. Each of these is a component. So you have an endomorph component, an mesomorph component, an ectomorph component. It is in that order. Note, endo, meso, ecto. Okay? Let's say we have a kid who scored 2.8 in endo, 4.1 in meso, 6.0 in ecto. The shape of this kid will be described here. Note the adjectives used. This is longish. Does that mean that this kid is necessarily very thin? For them, a lot of them are, but longishness has to do with your proportions. You have little girls that are short, but because of the leanness and the longishness of their bone structure, they are ectomorphic. Okay? They don't have to necessarily be tall. Endo, ecto, meso. In the order of the events, you always give the numbers in that order. Endo, meso, ecto. Now, apply that, put yourself in a Chinese recruiter, and you want to recruit the best gymnasts at 7 years old because you're going to get them enrolled in the National Academy. If you're recruiting for a specific sport, say you want to train the best weightlifters, which component will you be looking out for? Which index or which component will be critical for you? as far as when you recruit these children. So, a way to apply this is recruiting gymnasts, for example. Please take note. The scale that was introduced previously between 1 to 7 is a rather new development. Old data that have been published use the old scale of 1 to 5. So this is what I'm presenting to you in here. If you did your research as a Chinese coach or a Chinese recruiter, you're looking for gymnasts this time, not weightlifters. Which component is most important? Well, because it's empirically based, you're basing it on real data, and you're not leaving it to opinion but to science, in other words, measurable. Which component seems to be the highest for gymnasts who compete? International, from Canada, from the US, even from a third world country, the Philippines. So look at these numbers, okay? From this pattern alone, it is evident that the ectomorphic component is highly prized for gymnasts. So in that sense, this is how the somatotypes are being used. As I said, it's not so much here in the United States because for the good of all of us, it is still laissez-faire here. You want to play the sport regardless of your shape, go for it. So far, we've only talked about ectomorphies when it comes to gymnasts. Now, going back to the weightlifting example, we have to describe now the mesomorphy component. Meso having to do with muscle. So if you are recruiting for a weightlifter, you wouldn't want somebody who is longish. You want somebody who has heft, who has a certain proportion and a certain build that's more mesomorph, more squarish, heavy boned, and with a little bit, obviously with lots of muscles. So mesomorphy is the squarishness as far as describing this somatotype. Finally, the endomorphy component has to do with a roundishness. Recall the shapes that they were associated with. I leave it up to you from here to make your own examples. The question in the exam that will have to do with this is a very applied question, so meaning you be prepared to do your own math and do your own visualization as to which sport requires a lot of ecto, a lot of meso, a lot of endo.
Dear candidate, thank you for your application to our ballet academy. Unfortunately, you have not been accepted. You lack the right feet, Achilles tendons, turnout, torso length, and bust. You have the wrong body for ballet, and at 13, you are too old to be considered.
I just kind of showed you a short clip there. It's from an ad by Under Armour. And that's a good note to end this module on.